Welcome back to grade 10, physics session 9 we're in now. We're now going to be doing another one on circuits, slightly different to the previous one, but we'll just go through the recipe again. Okay? Essentially, when we see resistors in a circuit, we look and see if they're in series or parallel, and always our intention, our task is from putting the current in from positive to negative, we go through where they're in parallel, a current splitter. So we split it into I1, I2, or I3 if necessary, right? Then we look and we see, right, what have we been given? We put onto the circuit diagram everything that we know. They tell us the reading on the voltmeter is, put it in on the circuit, okay? The reading on ammeter 2 is 0.4 amps. You put it in over there. Because why? Essentially, everything that we are doing revolves around this. V equals I times R, right? So if we know I and R for any component, which is a resistor, which is either a resistor or a lamp bulb, remember that? If we know either I or R, obviously we can work out the third unknown. That's the process we go through, okay? So, first of all, we put the current in, okay? We write onto it everything that we know. Then we say, okay, do we know the resistors of the whole circuit or not? If we don't know the resistors of the whole circuit, we take a slightly different approach. If we do know the resistors, all the values of resistance in the circuit, we work out the effective resistance of the circuit so that we are left with this, right? Now we know R is known. Now let me put in my I. Now they might have told us there's an ammeter over there and the current is 0.5 amps and the resistance was 10 ohms. Therefore calculate V. V equals IR. This is a simple circuit. We do it for all of the circuits. We break it to where we've got V of a source, a power source, a current, single current, and one effective or total resistance for the circuit. And we would say V is equal to I, 0.5 times 10, which is going to be 2 volts. So it's a 2 volt battery. So doesn't matter, all we do is we find the unknown. Okay? Let us have a look at this circuit quickly. Okay? This circuit over here. Okay, let me draw it. First of all, they say we've got this. Okay? Here's our battery. And they tell us that this voltage over here is 20 volts. All right? Now, they will tell us that it goes down like so. There is an ammeter over here, A1. Then there's resistors in parallel over here. All right, like that. And this is 20 ohms. This is 60 ohms. Okay, and then we say, right, there's another ammeter over here, which is A2. And another one, A3, there. And this goes up here. And let us say they tell us that there's a resistance X over there. All right? So, okay, the reading on the ammeter A2 is 0.375. Hold on, they've told us that. So we say I equals 0.375 amps. Aha. Okay, and the reading on V1 is 20 volts, which is there. So we've put everything in. They told us the reading on the ammeter A2, there we go, and the reading on voltmeter V1 is equal to 20 volts. Okay, now they've given us everything that we need to know. Right, step 1, or rather step 2, is put in the current. There we go. I, I, like so. Right, now, the next step, okay, we say, oh, not all the resistors are given. Therefore, we can't use the formula to break it down to a simple circuit, can we? What have we got to do? We've got a different approach, okay? Now you look through the circuit. Go to each component in turn, okay? And when you get to the component, let's look, do we know V, I, or R? Over here, okay, I'm just going to put in my I. Okay, I goes there, correct? Because this is I here. And remember once again, I is equal to I1 plus I2. Because they must split in a manner that the ratio actually of the resistors. Okay, right, now let's look. No, I don't know V. Let's put in. I don't know V there. Right, now I go back and I say, okay, do I know, I'm just putting in green, the V, I, and R's for each component, right? They just pretend. Right, let's look. What do I know about this one, about where I2 goes? No, I don't know I or V there. Ah, here we go. Look at that. What have we got over here? At this one, at the 20 ohm. At the 20 ohm resistor, okay, at the 20 ohm resistor, what do we know? R is 20 ohms. V, don't know. Sorry, I wrote A for amps there. Okay. I say I over there is 0.375. Right, we know 2 out of 3. Therefore, V equals IR. V is therefore going to be 0.375 times 20. Okay, 0.375 times 20 equals 7.5 volts. Right? 7.5 volts. Now what do we do? The steps is go back to the diagram and put in voltage equals 7.5 volts. Right. Now what else? Let's go to the next one. We still know nothing about resistor X. Do I know I2? No. We know for the 60 ohm, we know the R. But you now know V. Remember what I said? The voltage across resistors in parallel is the same. So now at the 60 ohm, at the 60 ohm resistor, right, R is 60 ohms, okay? I2 equals don't know, but we know V. V is 7.5 volts. It's the same as across the other one because they're in parallel. Therefore, we say V 7.5 equals I2 times 60. Therefore, I2 is going to be equal to 0.125 amps. It is 7.5 over 60, correct? It is V over I. V over R. V over R. Right? Like that. 7.5 over 60. Right. Now, we go back and we say, right, now I know what you are. Okay? Let me put you in. You are 0.125. Now what do? We say, aha, we know that and that current. So therefore the current there is 0.125 plus 0.375, which is going to be equal to, okay, let me just have a look, is 0.125 plus 0.375 equals 0.5 amps. Okay, now you can see why it's important, because I now go and I put in over here, you are 0.5 amps. Okay, right, now let's look at resistor X. Okay, V, we don't know. X, we don't know. Okay. What can we do? The quickest way of solving this is to say, okay, let's look at it like this. Remember, the V across that one plus that V must be equal to 20. Okay? Remember that the voltage across resistor X plus the voltage across the parallel pair must be equal to V source. Right? The voltage across the resistor X, okay, the voltage across resistor X, this one over there, that plus this voltage, okay, because it's the same there and there, must be equal to 20. So therefore, I'm in the pound seats. I can now work it out. The voltage across resistor X, okay, let's say Vx, plus the voltage across the parallel pair, I think that was 7.5, must be equal to 20. So the voltage across X must be 20 minus 7.5, which is going to be 12.5 volts. Now we go back up and put it back in. We say, you are 12.5 volts. Now let's go back to resistor X. What do we know? We know the current I, 0.5. We know V is 12.5. So we can now work it out. Okay? We look, we say resistor X. Okay? What do we know? V is 12.5. I equals 0.5. Therefore, R equals unknown. Okay? And that in this case is X. Okay? So we say 12.5 equals 0.5 times Rx. Therefore, Rx is going to be 12.5 divided by 0.5, which I think comes out to be 25. Okay? 25. Let's have a look. So I'll just work it out. 12.5 divide 0.5 equals 25. Equals 25 ohm. Okay? Right. Now let's have a look. What is the resistance, okay, of the parallel pair? Just for example, let's go back and have a look. What is over here? Let's look at this. What is R effective here? Okay. Well, R effective over there was going to be, it's in parallel. So it is the R effective of the parallel pair. Let's look at parallel pair. They are in, so we've got 1 over R effective is 1 over R1 plus 1 over R2. Right? Let's see. That is 1 over 20 plus 1 over 60. Whoops. Okay. It's 1 over 20 plus 1 over 60. And that's 60. So that's 3 plus 1 is equal to 4 over 60. Therefore, R effective is going to be equal to, let's see, is going to be, what do we always forget? To invert. So let's invert it. Is 60 over 4. And let's divide 60 divided by 4 is 15. Okay? So the R effective is 15. Okay? Over there for those two. Right? Okay? So therefore, what is the R for the circuit? Okay? All right? The R total circuit resistance, okay, is 15 plus Rx, which we had, is 25, okay, is going to be equal to 40 ohms. All right? Now you could also say, therefore, V equals IR, because what have we actually broken it down to? We've broken it down to that one resistor of 40 ohms for the whole circuit, right? Now, therefore, if we say that was 20, and now we say, right, what is I? Okay, I, we say, all right, then you can say I is equal to V over R. So that's 20 divided by 40, which is half an amp. Okay? Just basically going to show that we can check it. All right? So how do we go about these? What do we do? Let's just go through the recipe again in the last few minutes of this. As I say, will be a section on test and exam preparation where we're going to just focus on solving the problems. Okay? I'm going to go through the recipes again and again and again. First thing, we make sure that all the information that we have, we put onto the circuit itself, onto the drawing. Okay? And if you need to, if there's not enough space from the workbook, just do the drawing quickly, but sketch it. You know, we don't sit there and draw beautiful lines and circles. We just sketch it. Okay? Then we make sure that all the information given is on there. That's critical. If we don't do that, we'll forget something important that's been told to us. Then we go, and the next step is we put in the current. We always put in I. Where I comes to parallel resistors, we split it into I1, I2, or I3. Okay? Then, where it's going through series, it's I, right? Then for each component, we pencil in a little V across each one, right? So we'd go V across there, and we'd go, if we've got resistors like this over here, all right, we would go, I'm just changing color again, we'd put in a pretend voltage there. And remember, that must be the same, okay? Because the voltage across a parallel set of resistors is always the same. Then we say, okay, if we've been given all the resistances, we can then go and we can work out, we can break those down into effective resistors. So we would go along and we would put in an R effective there. Okay? And if it's a series lot, we'll make those R effectives as well. Until we've got a circuit with one battery, one source, one current, and one resistor. Then we solve for the unknown. Okay? If they have not given us all the resistors, right, what do we do then? Right? Then what we do is we go to each component, each individual component. So we look at each resistor or each lamp bulb, which is a resistor. We look at it in turn, and what do? We put in, we ask ourselves, do we know V or I or R here? If we know 2 out of the 3, we can solve for the third. Do it. So we go and we start and we say, no, we don't know there. The only thing we know there is V. We don't know anything else. Or it could be that we don't know anything. We don't know V, I, or R there. There will always be a place where 2 unknowns are, or 2 knowns are there. Calculate the third. Then when you've got that, look, put it on your circuit diagram, and then look what you can do with it next. If you, for example, worked out a current now through one resistor and they're in series, it means you now know the current going through each one. If you've worked out a total resistance of a circuit, it means that you now can work out either the voltage because they'll have given you current and resistance, or you can work out the current because you know the voltage of the battery and the total circuit resistance. Hopefully you're starting to see the pattern that's evolving here. The pattern is one of you just apply the recipe. Go and find out what you know about each component. The key to remember is, first of all, if they are in series, they are voltage splitters. V1, V2, and V3. And the sum of all the voltages across the individual components must be equal to the voltage of the battery. Okay? Remember that. That's quite key. We use it in the last example. The next one is we say if they are in parallel, they are current splitters. The voltage is the same. So the voltage across this one and the voltage across that one is the same, which means the voltage across there and there is equal. So if you can work it out there, you can then say it's the same here and then carry on with it from there. Okay? Basically, that is circuits. As I say, in the exam prep and test sections, we're going to do more and more of these examples. Okay? As long as you follow the recipe, basically they're very simple. I've used ones here. The two examples that we've done are pretty good ones, and they basically show the process and the recipe to do it. Thanks for watching. We're going to move on from here now into the last section. Sadly, it's the section where a lot of people feel very confused and very unhappy. It's mechanics. It's basically Newton's law. Once again, I'm going to use a recipe approach to it. There's a few bits and pieces we're going to have to talk through just on the introduction. But I'll see you in session 10. And we'll go through that. And then we'll finish with physics. Thanks. And I hope that electricity and circuits is now basically pretty straightforward and pretty simple. Enjoy it. It is a big part, so it's well worth focusing on understanding this. Thanks. Cheers.